Welcome, everyone, to vpod.ai, and thanks for joining us for this deep dive. We've looked through the material you sent over, and we're ready to get into it. Just want to mention this deep dive is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup disaster recovery, hyper-converged VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, public and private cloud. Check out stonefly.com for more info.
Okay, so let's unpack this. We're talking about something that feels, well, right on the edge, brain-reading devices. The tech is moving incredibly fast, offering these amazing possibilities. But right alongside that, it's kicking up some really big questions.
Yeah, serious ethical questions
Yep.
about privacy, autonomy.
Exactly. What does it mean to really have control over your own thoughts? So our mission here, based on the info you gave us, is to explore that ethical maze these neurotechnologies are creating and look at some of the first global steps being taken to try and, get a handle on things. And it's that speed you mentioned that's key. This isn't just theory in a lab anymore, right? It's moving out, potentially into the real world. And it's happening so fast that our usual ways of thinking about law and ethics are struggling to keep up. It hits right at things we think of as, well, fundamental. Our inner thoughts, our choices, our autonomy. Understanding this shift is really crucial.
Absolutely. And you see the potential immediately, like in the examples from the material. That story about Ann Johnson. It's incredible. Stroke survivor, couldn't walk or talk for decades.
More years, yeah.
And then with a brain implant, she gets her voice back through an avatar. That was 2022. It's not science fiction. It's actually happening.
It's truly life-changing for people with severe conditions. And these neurotechnologies, that's the broad term, right? Because they interact with the nervous system. They're not just about speech. They're showing promise for things like restoring touch, movement, basically finding workarounds for damage. It's a whole new medical frontier.
Yeah, it really is. But like you said, that rapid progress, especially the last, 5 years, with companies like Neuralink getting so much attention.
And many others jumping in, yeah.
It's really put the ethics front and center. I mean, it's one thing in a tightly controlled medical trial, but it's totally different when you think about broader uses.
Exactly. The questions shift immediately. Okay, who gets this brain data? How's it used? Could someone misuse it? And these aren't just, what-if questions anymore. They need answers, like now.
Which brings us to that big development mentioned in the material you shared, that recent UNESCO meeting in Paris. Sounds pretty significant.
It really was. Delegates from all over, focusing specifically on hashing out ethical principles just for neurotech. It's maybe one of the first big coordinated global efforts to try and, draw some lines.
And these principles, they weren't just dreamed up there, right? They were developed with input from lots of different experts.
That's right. Scientists, ethicists, legal specialists. The goal was pretty clear. Set up a framework to protect people from misuse. Misuse that could violate fundamental human rights, especially things like autonomy and, crucially, freedom of thought.
Freedom of thought. Wow. I mean, imagine tech that could influence your choices or peek inside your head without you really agreeing to it.
That's exactly the kind of scenario they're trying to preempt. It's serious stuff.
And the mix of people involved, scientists, ethicists, legal folks, it shows how complex this is. It's not just a tech issue or a philosophy issue.
No, it has to be tackled from all angles. You need the technical understanding, the ethical perspective, and the legal framework, all working together.
So looking at the principles themselves, your sources highlighted a couple. One was about transparency. Developers have to be upfront about how they collect and use neural data.
Absolutely crucial. If something's reading your brain activity, even indirectly, you've got a right to know what it's grabbing and where that data goes. Basic privacy.
And another one was about long-term safety, but not just physical safety. Safety for your mental state.
Yeah, that's a really important one. We think about physical side effects, but directly interacting with the nervous system. That could have subtle, long-term impacts on mood, personality, how you think. Developers need to be responsible for understanding and preventing that.
That adds a whole new layer, doesn't it? Thinking about the mental safety over time.
It does. And Pedro Maldonado, a neuroscientist involved in drafting these, basically said the document helps clarify how existing human rights apply here. It's about extending those rights to cover our internal neurological space.
Okay, so where do these principles stand right now? The material says they're finalized, but not like legally binding laws yet.
Not yet, no. Think of them more as a global ethical guidepost, a set of recommendations that nations and companies can use to shape their own rules and policies. It's about building a common understanding.
Like a baseline.
Exactly. A baseline standard from a major international body. It carries weight, even if it's not instantly enforceable everywhere. That vote coming up in November, where the UNESCO member states decide whether to formally adopt them, that'll be key to watch.
Interesting. Now, the UNESCO discussion also made a point of distinguishing between different types of devices, right? Implanted versus non-invasive.
Yes, that's a critical distinction the sources bring up. You've got the implanted ones, like Ann Johnson's device. Requires surgery, electrodes directly interacting with the brain or nerves.
Right. And then there are the non-invasive ones, the wearables, headbands, earbuds, that kind of thing.
Precisely. Things using EEG or similar tech to measure activity from outside the skull. No surgery, generally seen as lower physical risk.
And the regulation is really different for these two categories, according to the material.
Very different, yeah. Implants, especially medical ones, usually fall under strict medical device regulations already. Think FDA in the US, similar bodies in the EU. Lots of hoops to jump through, clinical trials, safety checks.
Okay, that makes sense given the surgery involved.
But for the non-invasive stuff, particularly when it's aimed at consumers, not patients, the regulatory picture is much less clear. Patchy, really.
And that's where the concern comes in. I remember reading about Natalia Kosmina, one of the Neurotech experts involved.
Yeah.
Her point was about scale.
Yes, exactly. Her concern, highlighted in the sources, is that these non-invasive wearables could scale up massively and quickly. You know, a headband could become the next hot gadget almost overnight.
Unlike a complex surgical implant.
Right. And she stressed the need to really understand the infrastructure behind these devices. If you have millions of people using wearables collecting neural or related data, the potential for aggregating that data, analyzing it, and, well, misusing it on a huge scale, that's a much bigger worry than with individual medical implants.
Wow, yeah. That definitely raises the stakes. It's not just about one person's data, but potentially millions.
And that connects directly to some specific worries the delegates discussed, which the sources detail, like using this tech in schools.
Oh, how so?
Well, the recommendation is strongly against using it to evaluate students or teachers in ways that could create inequalities. Imagine judging a student's focus based on a headset reading.
Yikes. That sounds incredibly problematic. So easy to misinterpret or be unfair.
Totally. And another big concern was how even non-invasive devices might infer things about your mental state, emotions, stress levels, preferences, not just from brain waves, but from other data they collect.
What other data?
Things like how your eyes track across a screen, pupil dilation, maybe your tone of voice if there's a mic, heart rate, stuff some wearables already measure.
Yeah.
The algorithms are getting smart enough to link these non-neural signals back to likely brain states.
So it's not even direct mind reading, it's piecing together a picture from other clues.
Pretty much. It can infer a surprising amount about your state of mind without needing a perfect brain signal. It makes the potential reach much wider, even for wearables.
Which leads, I guess, to that really worrying application.
Yeah.
Neuromarketing.
Ah, yes. That came up frequently. Using this tech to tailor advertising or political messages based on someone's inferred neural responses, trying to influence decisions below the level of conscious awareness.
That definitely sounds dystopian. The idea isn't just a better ad, it's manipulating your response.
The fear is manipulating neural processes to make you more receptive, maybe timing messages perfectly based on your inferred mental state, all to boost persuasion without you even realizing it's happening on that level.
And the sources highlighted the scariest part, doing this without proper consent, maybe even, as they mentioned, while someone's asleep.
That's the nightmare scenario, isn't it? Influencing fundamental choices or preferences without knowledge or consent, it hits right at the core of free will.
So these UNESCO guidelines, they're really trying to put the brakes on that kind of future before it arrives.
That's the goal. They're not a magic bullet, not legally binding yet, as the material notes, but they are seen as a critical first step, a global acknowledgement that we need rules for this road, a foundation to protect our minds, our choices, our mental privacy as this tech continues to explode.
Right. So just to wrap up what we've unpacked from the material you shared, we've seen this incredible, almost sci-fi potential of brain-reading tech, especially medically, but we've also walked through the really complex ethical tightrope it creates. And we looked at these first important global steps by UNESCO trying to sketch out some ethical guardrails.
Absolutely. These principles are hopefully just the beginning, a foundation for protecting those fundamental rights as neurotechnology becomes more integrated into our lives.
And it leaves you, the listener, with a pretty big thought, doesn't it? As these devices potentially shift from vital medical tools to everyday consumer gadgets, maybe for focusing at work, gaming, who knows what else, what does that actually mean for us? For our privacy, sure, but also for our decision making, our sense of self, our freedom of thought. How do we make sure that reading the brain empowers us, helps us, rather than, quietly compromising that most private space inside our heads? That's the conversation we all need to be having.